Everyone. Welcome to our webinar. My name is Mary. I am the sales manager at WarmlyYours, and I'm joined today by our technical support engineer.
Hey, good afternoon, guys. I'm Anatoly. I'm with technical support and engineer, and I'm with the product development team here at Warmly Yours.
Thanks so much for joining us. Today we're going to be talking about our de-icing applications for roofs and gutters. This is to prevent ice damming with radiant heating, and this is going to go over talking about applications for residential as well as commercial applications. So we've got some questions that some people sent in ahead of time. We're going to be answering those as we go. If you have any additional questions, please make sure to bring in, tag us a message, and we will get to your question at the end of the presentation. So a little bit of the overview we're going to be talking about today is going to be the roof and gutter de-icing applications, the roof and gutter controls, pipe freeze protection, and pipe freeze control. So very similar, but slightly different. So stay tuned for learning how to do this. Here we got our roof and gutter de-icing. And why is roof and gutter de-icing so important? Really pretty much, I think it's because it's going to protect the roofs and gutters from snow and ice damage, prevents ice damming caused by poor drainage. It's going to shield the vulnerable areas in for the gutters, the downspouts, overhangs, and valleys, but that bottlenecks up between the roofs and the dormers. We've got some visuals that are going to show you this a little bit better. And so tell us a little bit more about the video, or I'm sorry, the image that we're going to be seeing right here.
Yeah. So those obvious damages that we're trying to prevent from is, of course, again, like I said, pretty obvious. We want to prevent anything that may be happening up there on the top that's visible. But on this image, you can also see those hidden damages that may cause actually, again, even bigger issues for the whole home where, that water leaks, it gets into the drywall plaster, wall cavities, all these hidden issues that really becomes a gigantic problem. But what we really like to talk and show in this image is the way the typical ice dam happens, right? You have any kind of precipitation, snow, ice, water, whatever that's on the roof. In our case, we mainly going to be talking about snow, of course, under certain conditions or simply because of that air leak that you see that heats the roof slowly. That snow will slowly start to melt, right? It's going to melt, cascade down the roof, and eventually get to the point. Hopefully, you can see my mouse kind of towards the gutter overhang area. That's where you now have very minimal or maybe no heat. So, of course, what's going to happen to that water or melted snow? It's going to flow, and get and refreeze here. And the more of that water or melted snow going to refreeze, the more ice going to accumulate. It eventually can accumulate to a point of an actual ice dam, like shown on that image.
Mhm.
And now you have the water that's kind of trapped and stays there. And as you know, water will find its way down one way or the other. So it slowly will try to find these different ways to sip through any kind of cracks, gaps, you call it, to hopefully not damage anything. But that's just the part of the nature. It eventually will get there. And of course, yeah, gutters will get all that ice. You don't want all that heavy icicles and everything building up in the gutter and other parts of the roof. But yeah, that's just a nice cross section telling you and showing you what happens and what we're trying to prevent. And again, I feel like I'm going to be repeating that a few times today through the presentation, but what we're trying to prevent is mainly to get that water safely out of the roof. So we're not trying to suddenly melt all your ice dam or melt all the snow on the roof. We're simply trying to create a safe path for that melted water, melted snow to flow through the roof into the gutter, into the downspout, and out of the house. That's kind of, if you want to simplify, that's main goal of this application.
Excellent. Thank you so much. So to do this, we offer two types of heating cables. We have what's called a constant wattage cable as well as a self-regulating cable. Um, the selection of cable depends upon the application in the roof material sometimes. Each is going to require a different style of clips, as you can kind of see there. And one other obvious real big difference you probably see there in that image is the one on the left, which is the constant wattage, has a plug that's just actually like an outlet plug that you're going to plug into your outlet. Whereas the self-rigging cable is not a plug-in. That one actually needs to have a power connection kit or plug adapter for it. So that's going to be a little bit of the differences between these two cables.
Yeah, and another thing I can probably add here, if we want to kind of add another differentiator here, constant wattage product is a predetermined sized product that we sell in a various lengths. You cannot trim or alter that product, so typically that's a great solution for your typical asphalt shingle roof that you have, particular size of the area that you're trying to treat. You did your numbers, which we're going to talk about just in a couple of slides. And like, hey, I need an 80-foot cable that's going to do the job. I have an outlet there. I'm just going to install it and plug it in. All ready to go. You, of course, can accomplish the same exact thing with a self-regulating product, but let's just say you actually trying to treat the roofs and overhangs, downspouts, gutters all across maybe a larger house or something. That's where the self-regulating cable really comes in handy because it's a cut to length product. You can trim it, kind of divide it in separate sections or run longer sections at a time. Again, we're going to talk more in depth, but that's just another piece of the kind of advantages for each of those product types.
Excellent. Thank you, Anatoly.
Yep.
And looking a little bit closer here at the constant wattage cable, you can definitely see it is a different construction altogether. This is going to have the over jacket, the PVC outer jacket. It has a braided ground. It has an insulating sheath, and then it has the actual heating wire, and then what is called a bus wire. Um, this type of constant wattage cable is not for use on a metal roof, nothing on a slate, stone, ceramic, rubber, tar, gravel, or wooden shingle roof. So, Anatoly, what does that leave us?
I mean, that mainly leaves us to these asphalt shingle roofs, right? That's like I was saying before, that's kind of this main application that this product should be used, just because that's the most typical application, and that's where you really have that flexibility to install the predetermined cable length in the manner needed based on the proper calculations. Another thing to probably add to the constant wattage here, to the technical side of things, is the name itself, right? Constant wattage, right? This cable, as soon as it plugs in, as soon as it's getting power, it just heats up and stays at the constant power output, right? So that's where, for example, you should never be placing two cables overlapping, right? Because you now will have a point of literally double heat being generated, and that can cause overheating and potential damage to the cable or overheating of the cable itself. That's where, again, you simply would apply the basic installation instructions technique to install the cable without overlapping and get your area treated as required.
Very good. Okay, and then here is our self-regulating cable. This is going to be similar but different. It still has the black outer thermoplastic jacket. It's got a braided inner tinned copper braid. I would think that's the ground, right?
Yep.
Thermoplastic insulation, self-regulating semiconductive core, and then it has the copper bus wire. So really what's different about this one is it is that semiconductive core that is regulating, if you will, the temperature. Um, and the difference, again, this cable can be overlapped, it can be crisscrossed if needed, and it's trimmable. You can trim to length because what's happening there is the conductor core is really what's making it heat, right?
Right, right. So yeah, this I think if we want to simplify that cross section, let's just talk mainly about that core, right? The core is where the heat is generated. The self-regulating cable, the whole kind of nature of that cable is different than any other heating cables or systems, right? If you're familiar with floor heating or slab heating or snow melting, you know that the actual heating elements are those main wires. This is not the case here. Those are not heating wires or heating cables or elements. Those are just bus wires where the power is being delivered, but the core in between is where that power, eventually that voltage is flowing from one bus wire to another. And this is where the heat is happening. And again, this is where actually the name self-regulating sort of comes from, because this core reacts differently and simply heats differently depending on what temperatures and what it's exposed to. So any section of that cable that's exposed to, let's say, colder temperatures or sits in the chunk of ice or snow, this core will generate more heat, will generate more power. And any section of it that is more maybe exposed to warmer temperatures or sits on the sunnier side, it's going to use less or very minimal power. So just again, a lot of people kind of like call it magic, right? Because you can have one section of the cable, maybe it covers kind of two different sides of the roof. What's going to happen out of 100-foot piece cable, you may have 50 feet that sits on the sunny side, literally using any power because you probably have a clear roof there. Nothing needs to be done at that particular time. And the other section may be sitting in the kind of shaded section where it's a chunk of ice or snow that needs to be melting. And that's where the cable is just going to deliver its maximum power output to do its job. So again, it's a very, I'm going to call it eco-conscious selection on the product, because you're really having the product do the job for you by self-regulating what needs to be heated in the given moment. And yeah, in the end of the day, it's just heating very economically. It can be overlapped, it can be crisscrossed, because the cable will react to itself pretty much and never overheat. So again, great product selection for maybe medium, larger commercial applications and so on.
Excellent. So we have some things people always ask us in the sales department is, how do I measure for a roof de-icing system? They call us up and they say, I've got an ice damming problem. How do I get a quote for it, basically? So really what we need you to do is get us some good dimensions of the roof line. We're looking for along the roof line. So the overhang, which is very important. As you can see, that letter A, that's kind of showing us the distance of the overhang from the eave to the side of the building. That's the section, if you're overhanging, that's going to really ice up. So we need to know that eave, so we know how high up to put that V um, cable. We need to know the distance around any dormers you might have. So any of those like valleys or dormers, those are spots that you're always going to have some ice damming trouble. So please be sure to call those out on your plan or drawings. Um, we also make sure that you count all your downspouts, because we will also go, along the roof line, and then, sometimes we will go down the downspout and then maybe back up if we need to continue on with the cable, if it's a very long building or roof line. Um, some photos are always helpful. If you can take a couple, quick photos and include those with your quote request form, that is going to be very helpful for us to help get you the most accurate quote. Other things, of course, we're going to ask you is pitch of the roof, type of roof, metal, asphalt, shingle, all that. Um, and some of the other things. What else do we ask, Anatoly?
Yeah, I mean, you really covered it nice. These are the most important thing for us to properly calculate and design and provide you an estimate kind of how much cable you need and any additional parts needed. The good thing we always try, and we do our best to kind of make it easy for you. We have a very simple form for those type of applications that is available in PDF and online. As long as you fill it out, all of it or most of it, that will give us all those valuable pieces of the puzzle to provide first of all proper design, because we're not trying to just like estimate and tell you like, hey, you need about 500 feet of cable. What our design team will actually do is they will with a sketch and proper dimensions, they will draw an exact cable layout because that ensures that we not overestimating and giving you like extra cable that you may need to kind of go up and down multiple times for no reason. We actually trying to make it as efficient as possible so it hopefully in the end kind of creates a logical loop, right? Like if you would start in the left section by where kind of left B is pointing to, go in the zigzags, maybe cover the valley in the D, go around the dormer, then drop into the downspout, which marked E, and then follow the gutter all the way back to where you started. You kind of create a loop without going anywhere two times, maybe except that downspout where the E is, which most of the time is not possible to avoid. But that's our goal. We're just trying to get you a simple layout, which first of all ensures your installer will spend the shortest amount of time possible getting that installed. He would not need to figure that on his own. We do that for you, and that ensures that we get you exactly the right amount of cable that's needed.
Excellent. Yeah, so from when you send in your quote request form, give us that drawing and sketch, fill out the form. Within 24 hours, we can typically turn that around and get you back your quotation. And that's going to include that smart plan. And also on there, it's going to have all the electrical requirements and breakers that you might need as well. Another thing you might want to point out on your drawing or sketch to us is if you know where your power connection might be or your outlet might be, that might be helpful for us to know as well sometimes. So we start the cable where it's going to be convenient for you to bring the power to it.
Yeah, good point about power, Mary. Thank you. Another thing I can probably point out, I've definitely seen sketches from people where, we're gonna treat that overhang in your typical zigzag pattern, right? But many times I would see a sketch where the customer already knows that, like maybe in that corner by the valley there, that's where the majority of the problem happens. That's where majority of the snow is or ice starts to accumulate. So what they will do, they will mark up and kind of highlight that this is the area where, the issue is slightly bigger, right? So what that gives us, what information this gives us is we're going to estimate slightly extra cable, or maybe we're going to go with the zigzags a little higher. So it's always good to, if you already know some existing or simply historical feedback on what's happening where, share it with us. It's never a bad thing to just simply get some extra cable into those areas. And we actually had a question ahead of time from Todd who asked us how to quote these products. So hopefully we I feel like this slide already answered this because yeah, all of these steps that we just outlining is the steps you would want to follow. Again, to make it simple, you can just reach out to us. We're going to get you the form, or the form is available right on our website to fill it out, and the quote typically will be ready within 24 to 48 hours. And if, in case your question, Todd, was also in relation to the pipe trace product, we can talk about that in just a couple of slides. I know also we had a question from Brian who asked about installation method for metal roof systems and how to measure for each section. That same approach, Ryan, pretty much will apply to the metal roofs as well. The only additional pieces of information that you're going to see on the form would be, of course, the spacing of those seams on the metal roofs, because that will help us to understand how much cable is needed, because the cable will eventually go up and down the seam. And that's what you're actually going to see on our next slide that actually covers and shows you the metal roof section.
Yes, here we are. Okay, so this is going to show you a pretty good example of the de-icing cable. This is the self-regulating. This is not the constant wattage. This is secured with the clips that we include for your system. These are the aluminum prong clips. Those are adhered with a really heavy-duty double-sided bonding, um, double-sided tape pad, we call it. You make sure the surface is clean to adhere the pad and put the clip on. You're going to see probably about 5 clips every time you do a V point. Um, we're going to show you what's recommended in the manual, and we'll include enough clips to do that in your quotation. You're going to extend these clips into like a drip loop as well. So you do need a little bit of extra to go like around some drip loop areas and going up and down through your downspouts. So it's pretty easy, three-prong bended clip just to show you how to fasten it down in there.
Yeah, yeah. This application actually, as you can see, it's of course again on the metal roof. You can see there are those tiny snow guards, which are kind of like a pad style snow guards. As you can see, this is not some extremely steep metal roof. So the roofing company would pick what's appropriate to prevent that snow or ice from sliding, if that's of course the factor. But this is a good slide also to connect with another question from Brad, who again send that question to us ahead of time, which we always appreciate. We want to get those any of the questions we want to get, and if we get some of those ahead of time, that's always a bonus. So Brad was asking about the installation on the steel, or again, we assume on the metal roofing installation as well. He had some feedback or heard from people that when the ice melt or snow melt slides, it also pulls out the wiring. He's looking at how this is prevented in our application. So yes, good question and very definitely a good valid concern, right? Snow sliding is always a thing. The snow melting system not necessarily gonna just suddenly solve that, because if you have, especially if we're talking about some larger snow amounts and you now suddenly have a foot of snow there, and again, I feel like that's the first time I'm repeating my statement here from a couple of slides back. I was saying before that we're not trying to melt the snow. We're trying to provide that safe path for the melted snow or water to flow, right? So if there would be a foot of snow kind of to the right or anywhere on this roof, we're not necessarily trying to melt all that snow. We're trying to prevent these pretty much channels for the water to flow, which means if that's some chunks of snow still staying there, there still need to be those roof guards or snow guards prevention methods in place. And that's why you see that here. That's why you're going to see a different style of snow guards, like pad style or bar style, or especially if it's a larger snow mounts, you may see things like a fence style snow guards that literally hold the snow as a fence there to prevent any damage or sliding or simply sliding into people or anything. So pretty much what I'm trying to say by all this is that you still want to incorporate whatever snow guard style is needed or required or simply recommended from your roofing company. Because what happens, again, if we're talking about heavy mixture of snow and ice that suddenly sliding off the roof, and you can only imagine the weights and force that's happening there. Uh, and let's just say you did not secure the cable as required in the instruction, that force of snow or ice sliding is very likely going to take the cable with it. So you don't want to take chances and install the cable, spend all that time and money for that application, but then not treat the roof as it still should be treated with the proper snow guards. And then suddenly you get to the point where that snow slides and takes the cable with it. So still, again, these are, I think to summarize it, these are two different applications. We providing you a heating system for your de-icing application, but the proper snow retention or simply snow safety on the roof still need to be done to prevent that combination.
Very good. Okay, so another question we always get is who's going to install this for me? Everybody knows they have a ice damming problem, or last winter you had a big problem, and we're talking about it now here in the middle of summer because now is the time people are putting in their new roofs and putting on their gutters and getting prepared for next winter. They want to know who can put this up. So the typical electrical cable can installs without an electrician. And that says it's the cable we do actually want an electrician to help you with. Um, Usually it's going to be a roofing guy that might put up the cable. So sometimes it's two different contractors, sometimes it's a roofer or handyman um, who will put the cable on the roof. Other times it's going to be the electrician who's going to come and actually do the connections for you. Constant wattage is going to be a little easier. That's going to be a little more DIY friendly. Um, if you're just trying to get a little bit, up there on your own and you have an easy way to access to a plug, constant wattage is a simple and easy way to go.
Yeah, and I like how this slides kind of connects a little bit to what you already mentioned before, Mary, about that power location. So let's just say you may have, again, a separate party just getting your cable installed. Let's just say it's a roofing contractor. You still want to get that feedback or insight from an electrician about the power locations, or maybe even if it's a constant wattage, like where that outdoor outlet will be planned for, or again, if of course if it's a self-regulating cables, where those best locations for the start point or junction boxes to be. So always good to have kind of these parties kind of communicate with each other, or simply jump with us on the one of the pre-planning meetings that we always try to do, where we try to involve those different parties, have everybody on the same page, make sure that we doing the plan that simplifies the life, simplifies the install for all of your parties.
Very good. Okay, so let's talk about the controls and sensors. And this is where we kind of will guide you to what's best for your project. The outdoor controls and sensors for roof and gutters, we offer several different things. We have the premium control, we have timer controls, economy control, Wi-Fi controls, our advanced controls, outdoor thermostat. Um, Compatible sensors detect moisture and temperature. So we have aerial sensors, gutter sensors, and moisture sensors. So there's a combination of ways that we want to operate your system. Sometimes we do want that aerial sensor so that we know that there is moisture and precipitation coming down. That will activate it. Having a gutter sensor is going to detect the moisture in the gutter. So sometimes you need both. You might need the air sensor as well as a gutter sensor. And so tell us a
Yeah,
little bit about why it's beneficial to have both sometimes.
Yeah, I mean, having both sensors gives you that best snow detection, because what happens then is when one of the sensors, you don't need to pretty much simultaneous input from both sensors, but if one of the sensors is getting that snow ice detection, then the system gets triggered. So you may have the situation where it's, free falling snow, both sensor most likely going to get triggered about the same time, system going to kick on. That's great. You may have a situation where there's no free falling snow, which means your aerial sensor probably not going to get triggered, but your gutter sensor may get triggered because maybe it's kind of that freeze thaw type situation. Some of the snow starts to melt or drip onto the gutter, things like that. And that's where that gutter sensor sits. So it's going to get triggered, which is great because you don't want that, pretty much back to the slide one, right? You don't want that ice dam issue to start occurring. So yeah, combination of both is probably ideal. Gutter sensor is a great start because that really detects the
Right.
situation in the most, in the most important spot.
Right. So think about like when you're in the, winter months and, it's an early sunset. So like right around, 3 p.m. or something like that, that sun might be warming up and melting some of that roof. And then, an hour later, that sun is down and there goes the refreeze. So that moisture sensor in the gutter, is definitely going to be key because there's not necessarily going to be precipitation coming down. All that ice and melting is happening right at the gutter.
Yeah, good point. And I think real quick, one thing I want to add simply to just make the selection again, like Mary said, we try to select the best setup for you. But if you're just trying to do your, of course, own research and prepare for the project, I like to separate the controls simply into an automatic controls and manual controls, right? For most of the time, for your typical residential commercial applications, you very likely want to go with the automatic approach because the last thing you want to happen is, you invested all this cost and time into the application, but then there is some unexpected weather event, or simply you're not there to turn the system on, and now you suddenly have the system that's not running when it needs to be running. Like for me personally, that I feel like that's going to be pointless, right? So automatic control is generally would be your number one selection. So always go for that. The rare times where I would see people going with the manual Wi-Fi or a manual timer control would be if it's really, I want to say, like a precautionary type system. Maybe it's a smaller system on just one side of the roof where, you know, 1 or 2 times a year you get some very odd snow event, and some, again, some snow or ice accumulation is happening in the valley, and you wanna get that treated. That's the time where I would hear people going with, again, some sort of manual controller and turn it on their own, and that always apply for really situations where people would be staying there most of the time. It's not a vacation home or something. They know when to trigger. So again, make it simple. Just simply divide into automatic, where control does all for you, does it in the most economic fashion, versus manual, where you're really in charge and control of your system.
Very good. Okay. So here we're talking a little bit about the residential applications, ideal for roof edges and heavy snow areas. It's going to reduce the icicles, supports drainage, extends the roof lifespan by preventing the damage. And here's just a really good visual picture of, this is actually showing the constant wattage, it looks like, cable on
Yep,
an asphalt roof. Um, and as you can see, it's, definitely doing its job there, melting away so that the snow will just trickle down into that downspout and drain away.
correct. Yeah, good visuals. Again, that's probably my second time confirming the theory. Safe path is what we're trying to do. As you can see on that image in the after application, again, we're not trying to melt the snow. We're trying to get that prevention of ice dam happening here and get that melted snow draining away.
Very good. And here's what it kind of looks like on a commercial application. As you can see, the before picture, major icicles and issues over there on that roof. And then the after photo you can see there is it's nicely drained. You can even see it drip, drip away right there out of that downspout.
100%.
Yeah, and it's definitely doing its job up there now. So that is really the difference. So you're going to plan for the electrical load and circuit capacity. So when you're thinking big commercial projects, think like, oh my gosh, is this like an enormous, giant warehouse? Are you trying to melt the snow off an Amazon distribution center, or are you just, trying to, melt the snow off your garage? Um, they're not designed to melt deep snow on a flat roof. So don't think of like snow removal once again. This roof you're seeing in this picture does not have a very high, pitch, but this is not going to be snow load removal by any means. So if you're looking for a product that's going to take the weight off of your building, this is not going to do that. Um, Many require several starts and stopping points. So sometimes, again, depending on the size and shape of the building, we may, run 100 feet of cable, make a termination spot, start again with another, cable somewhere else. Sometimes they can be connected to the same main control panel. They're going to run into a junction box, but we may need several starting and stopping points, just again, depending on the large size of the application when you're talking about commercial projects.
Yeah, good info. Again, the commercial application, we mainly, let's say, talking just about something larger. We would typically, when it comes to a planning design process, we would start with just estimating kind of, okay, how much cable in total we roughly need. That will tell us how many sections of cables would be needed, or simply separate dedicated circuit lines. And from there, we, of course, let's say we did this basic estimation. We know, hey, we definitely need at least 3 or 4 circuits. That would be a great input for us to simply share with the electrician and understand where those start points, 3 or 4 start points may be. And at this point, we will start and create a good layout that makes the whole installation and planning simple. So again, getting that extra information is great, and we always try to work with you in a simple logical steps to prevent us like designing something extraordinary and then electrician just getting shocked because it's like, hey, this is not what I was planning, right? So we try to align all the parties on the same page, get the information required from everybody, and then prepare pretty much a nice plan, nice layout.
Right. And something else I might just mention too is that the cables
Yeah.
are the self-regulating, is sold by the spool. So, you're going to buy a bigger spool than what you might need. And you may use a portion of it in one spot and a portion of it in another spot. In other words, we would rather sell you like the larger spool, if you're going to use it in multiple places than two small spools, for example.
Good point. Good point. I feel like we didn't touch on this particular benefit of the product too much. So yeah, self-regulating cable specifically is the cable that, yes, like Mary said, sold by spool, but it's cut to length product, meaning that you can cut it to the length you need. You can, again, we will estimate and do all the planning for you, but things happen, right? Maybe there was some drain or downspout miss, right? You now operating with a spool of cable that you keep installing and installing until you either hit the end or until you hit some termination part of the project where you just cut the cable and terminate it. So I think what we're trying to say, it just gives you so much flexibility. We still do all the work for you for the preparing a design and layout, but the great thing is you can continue installing worry-free that something unexpected or some last-minute changes are happening, or some new places that needs to be treated or founded. You still can do the job, or if it needs to be terminated earlier, you can do that as well.
Yeah. And I see a question just came in from Ryan, and he's
Oh,
asking about for metal roofs, do I have to use self-regulating cable? Yes, right? We do have we're not using the constant wattage on anything
correct. Yeah,
much but an
the
asphalt roof.
metal roofs, the constant wattage product is not really made for that application. So yes, correct. For metal roofs, you definitely would want to go with a self-regulating product, and definitely indicate if it comes to quoting process or so, indicate that it's metal roof, indicate what seam spacing it is, and of course all the other additional stuff that we covered, like an overhang. All these kind of components gives us the proper way to get that designed.
Excellent. Awesome. Okay, so let's move on and talk a little bit about our pipe freeze protection. Um, Anybody who's at a burst pipe knows what a mess that is. Nobody wants to experience that. And it always happens when it is polar vortex season around here, or you went away to your summer cabin and you're away now because it's closed up. Well, you want to make sure that your cabin, you don't come back next spring and have a disaster to walk into. So pipe freeze is very important. We want to make sure that we keep the water flowing, and that the pipe doesn't burst. So what the cable will do, it keeps the water flowing when you have poorly insulated or cold conditions. Um, a lot of people also call this heat tape or heat trace. There's a couple different verbiage for this product.
Yeah,
Um,
trust me, we've heard all sorts
yeah,
of names and words related to heat and pipe and tape, right?
heat tape, heat trace, pipe freeze. It's all the same thing here for us. But this is basically maintaining the pipe temperature to prevent freezing. It doesn't have to keep it hot. It just has to keep it just enough so that there's a trickle so that the pipe doesn't expand and burst.
Correct. Yeah. Yeah, let's talk about those types of cables, and then we can kind of really dive into some good technical information about each type of the cable.
Yeah. So again, kind of similar to what we just talked about with the roof and gutters. We've got self-regulating, constant wattage. Again, once you can see constant wattage, is going to have that big plug at the end. Um, Self-regulating looks like that bus wire with the inner core that's heating up just like it was for the roof cable. Self-regulating. Um, these are for external pipes only. Another thing we get asked all the time in sales is they have a pipe that they want to that's buried in the ground, and they want to put cable in the pipe that's already buried in the ground. This is not to be inside the pipe. This is to be on the outside of the pipes. Constant wattage or self-regulating, same thing on the outside of the pipe. Um, and same options for like roof and gutters, for controls and
Yeah,
everything.
yeah. I think what good to know here is, first of all, kind of bonus question or bonus answer here. The self-regulating cable, the product itself, is actually the same product that you would use in a roof and gutter de-icing application. and a pipe tracing application. The
Mhm.
main difference, or simply add-ons, is that in the pipe tracing application, we also provide 2 additional higher wattage variations of the cable. So let's just say it's a really maybe of a commercial or industrial application where we're talking about some really large diameter pipe. Maybe there's minimal insulation or so. That's where a really more powerful cable is needed, or potentially even a double run of the cable is needed. So that's kind of the only difference would be in this product category. But if we're talking about a standard self-regulating cable, it's actually, believe it or not, it's the same type of cable that you would use on both applications. And when it comes to the types of the cable, or kind of main features of the cable on the constant wattage, another difference, if again, if we're simply trying to compare it with a simple cable with a plug, here you have additional component, which is the thermostat, or simply a sensor that turns the cable on and off when the conditions call for it. So we're going to talk about that in just a couple of slides, but I believe I saw some pop up. Do we have another question, Mary? Let's see.
Yeah, I think we
Yeah.
do. It's Ryan's asking about the snow retention. I think we kind of covered that. That was about the snow guards,
Oh,
the
yeah, yeah.
stoppers. Yeah, we would recommend something like that just to make sure that the cables don't get ripped down if there's a large packing of ice and snow, and it was to slide off your metal roof. You will still need the snow guards to make sure that they
And I
don't.
believe it looks like Ryan is, if correct me if I'm wrong, but Ryan, I think, is trying to clarify if the snow retention should be installed before or after a heating cable. And I think the answer here is pretty simple. Yes, you definitely want your snow retention system to be kind of fully installed and done before the cable installation, because that first of all, that's safer. You're not going to get to any situation where the cable is there, somebody gets the snow retention installed, drills or damages, or does something to the cable. That's like number one obvious, I think, thing for me personally. But yeah, after your snow retention is in, then you have the final route to get that cable installed and secured properly. So yeah, snow retention first, and then continue with the heating system installation. Good question, Ryan. Thank you.
Mhm. Okay, and let's go back.
So what do we do? Yeah, let's now dive into the constant wattage, Mary.
Okay, so constant wattage. This again, we're going back to DIY friendly. So think like your anybody living on a farm maybe needs to make sure that their uh, well pump or something to the animal feed outside. That's a problem I might have. That your water pipes don't freeze getting out to your barns and things like that. So a lot of times constant wattage is a great opportunity to use that on those kind of pipes. DIY friendly. The nice thing is if you saw in that picture that has the plug, you can kind of see there's like that orange like fat part that actually has a built-in thermostat for energy efficiency. So you're plugging that in and that plug actually is working as the thermostat for it. Um,
Yeah, one thing I want to quickly point it out, we're going to have that in visuals just in a few moments, but like in case you're looking at that now, we trying to use the visuals that of course shows you the pipe, the installation, how you tape that to the pipe and the cable itself, but we don't show the insulation that is always needs to be used when you finishing everything up. Of course, we're not showing that because you're not going to see the cable there, but that the insulation should always be used, because that's how you actually using this heat properly, right? You have the cable, you correctly attach the insulation, you secure that insulation, and that's how that heat is trapped and stays there. You never should be just applying the see, I'm already using this different terminology, heat tape, I wanted to say. You don't want to install the heat cable and just kind of like leave it exposed or leave it whatever, just taped to the pipe, because probably 10-20% of that heat is only going to make it to the job instead of 100%. So very, very important factor. And like I said, you're going to see that in the future slides here, but I just wanted to point out because yeah, that's the visuals we use just to show you the kind of inner workings or halfway through the install.
okay. So this is a bigger difference of a picture here. As you can see, this is kind of going around that um, valve there. So this is the self-regulating cable, once again, cut to length for easy installation, energy efficient, lower operating costs, prevents um, overheating because you can't overlap it. So when you got to loop around a valve like that, you're going to need to use the self-regulating since it can crisscross. Whereas once again, same rules apply, constant wattage can overheat if you try to crisscross it. So that's a bigger difference on this. And again, just like Angela says, we are still going to wrap this pipe, right?
Yeah, yeah. It's going to
Mhm.
be wrapped in the insulation. I think, again, talking about self-regulating and maybe larger commercial projects, or simply, let's just call it larger projects, right? Longer pipes. This is where the self-regulating, that benefit of the product becomes even more, visual, right? You have a long pipe. If it's whatever, it's coming in or outside of the building or anything like that, you're probably going to have one end of that pipe colder than the other, right? Because maybe one is more exterior than the other or anything of that nature. That's where that benefit or advantage of the self-regulating cable becomes really prominent because you may have, and again, let's just say it's a long pipe, right? Let's say we're using 300, 400 feet of cable. You will have a section of that cable that really needs to work overtime and heat at the highest wattage. It will do its job because it can sense that. But maybe on the other end, it's already warm. It's more indoors. It's everything is flowing there. Everything is good. That's where the cable literally gonna kind of idle, right? So that's where those operation cost savings gonna get really visible, right? Because you now not heating the whole length of the pipe at the same temperature, and like one end is flowing and the other end is suddenly like, oh, we are warming that water now. You don't need to do that, right? For maybe your typical cold water pipe or something. So again, self-regulating is really, really good approach here.
Excellent.
Uh, I know we're kind of diving into some questions here with the in the middle of pipe freeze, which is completely fine because Ryan has another question. Let's just check it out. Ryan is asking, is the snow guard recommended for both asphalt roofs as well as metal? Again, that's a good question, Ryan. We are not necessarily in the snow guard business kind of thing or recommendation, so I don't want to give you some false suggestion. All I can think of is that there's less chances that asphalt roof may need one if I would just compare it one to the other. But that determination should probably be done by the roofing company depending on probably different factors that they know better, like the pitch, the type of that asphalt shingle. So I'm going to say there's less chances you may need one, but it doesn't mean you don't need. And that's again, I would definitely double check with the roofing company or even with the asphalt shingle company. They may know how good their product holds the snow and when what's recommended. So hopefully that answers. We trying our best, but we don't want to give you just some estimate false information.
Very good. Thank you. And here's that good slide we were talking about.
100%.
Um,
Yeah.
this is number one. Okay, that fat part right there. What's going on there? That's going to be the thermostat regulator, right?
Yeah. Yeah. That's where the sensor sits.
Okay. And then number two image here, this is the insulation. That's like a roll of fiberglass, right? Or something. What do they call that? Insulation.
There's I think different. Yeah, fiberglass would probably be at least one of 5 different insulations that I know that can be used for pipes. But yeah, eventually,
You'll find
it
it. Yeah.
yeah, it what applies to your pipe or your building or maybe what code requires. So once again, that's another side of the area that, we're not necessarily in this type of business. So we wanna inform you that yes, insulation is needed, but that insulation type and everything should be determined by maybe a plumber or your code inspector just to do the job right. Our goal, our intention, of course, as you can see on those images, is that the insulation is properly installed.
Yeah. So they're just kind of giving you an example of what to look for, what to use.
Yep.
And yeah, so then it's just basically tape it up, wrap it up, seal it up and plug it in. Very easy.
One good to not necessarily fully visible, but the pipe trace constant wattage product has a lighted plug, so that's another benefit for you to eventually see when the product is up and running and operational. Usually maybe required even by code, but it's just a great visual attention spot for you to know that your heating cable is running right now.
Right. So it's plugged in. You should see a little light on the plug that actually shows it's on, correct?
Yep, exactly.
Okay, great. All right, and here's some of the controls and sensors that we use for these systems here. We have this is um, one of the heat trace controls here. This can do, we have pilot duty versus direct connect, which I'll let Anatoly talk a little more about. What's nice about these is we have some options that have the GFEP already built into them, and operational moisture and temperature sensors for automation, similar to what we talked about on the roof systems as well.
Yeah, let's just quickly dive into the controls and sensors here. So the mainly the pilot duty versus direct connect that just kind of tells you how the system will be connected through the control. So pilot duty simply meaning that it's going to be a control that controls the maybe an array or simply two or three relay panels that have multiple cables installed to it, or in some cases, the building or code may require that each separate cable runs on its own control. So that's just kind of one approach on how that can be done. And of course, direct connect would be that second way of doing things where you have a heating system, heating cable that gets connected directly to the controller, and that controller just controls this one section, this one section of the building or pipe or something. So that's just kind of the simply two main ways on how the system can be wired. But yes, most of these industrial light commercial controls, they will have a built-in GFEP, depending on the type of the system and type of application, I should say. You can have your more or less simple freeze protection system where or control where the goal of the control is to sense the temperature and make sure it never drops below that kind of melting point. Typically, it would be predetermined 38, 40 degrees or so. Some controls will have just like two or three main settings to adjust in case you want to just vary that a little bit, and more of kind of commercial industrial controls that maybe you're not necessarily doing just freeze protection, but you're doing some kind of temperature maintenance where you're actually trying to maintain a certain temperature. These controls will have the temperature selection. So like you can see on this control, you have kind of up and down buttons that literally lets you adjust the set point at which you want to maintain and run the system. One thing to probably point out is that the controls and sensors, that's something that's applicable, of course, for your self-regulating system. Because as you know, once again, constant wattage just gets plugged in and it already has a sensor, so it's all automatic. But that's the selection of controls and sensors that's going to be for your larger self-regulating setups.
Very good. Okay, and residential applications, outdoors or indoors, prevents water damage and pipes bursting. Um, Oh, here it is. Yeah, use a half-inch fiberglass or equivalent non-flammable insulation. So again, we're not telling you exactly which kind to use, but it's as similar to a fiberglass half-inch style non-flammable insulation. You're going to wrap it in a wrap style pattern, just like we're showing here. Um, Another thing I think old school method people used to think about pipe trace was wrapped around the pipe. That's what I always thought, like I guess years and years ago. And so we got smarter and we just realized like, yes, it just needs to go along the edge of the pipe so that it's just melting at the lowest point, kind of where the liquid would be in the pipe.
Correct.
There we go. And then here we got some commercial pipes. So this looks more like almost like a foam pool noodle kind of, but this is actually what they would call plumbers insulation foam, I believe they call those. Wraps or plumber wrap, maybe they call it. Um, you're going to plan ahead for this electrical load and capacity. So when you're talking big projects, you're going to be talking larger power requirements needed, um, longer cable runs, higher power demand. And this again is when we get into the higher wattages. So normally you're talking just 5 watt available, self-regulating. When you get into commercial, we may be doing like an 8 or a 10 watt. Once again, depending on the pipe, um, depending how, how wide the pipe is. If you've got, a diameter pipe that's like sewer pipe or something big, you're going to need maybe 2 runs of cable to go over that.
Yeah, and I feel like that's the kind of quoting setup section. We don't necessarily have an exact slide, but I know what was the question. We had a question from Todd one that we kind of hopefully partially answered on the roof projects, but in case that question was for the pipe trays, how to quote these, I'm gonna just repeat that. Yeah, that was the question. Uh, the quoting process is kind of, I want to say, the same, right? We want to know, we first of all, we will get you the form, a very simple form.
Mhm.
This form is also available online. That's where mainly what we want to know from you about those pipes is the length, the diameter, what type of pipe it is, what type of insulation is being used, a few additional things like, different supports or temperature it could be exposed to. But mainly how I like to kind of talk about this, mainly why we trying to get all this is because if you're familiar with the concept of kind of calculating the heat loss for a home, it's kind of the same thing, right? We're trying to determine how much heat we're losing here to maintain that flowing state. And we then simply trying to match or overcome that with a heat tape. So if we know this pipe is kind of losing about 5 watt per foot, we're going to get you a cable that maybe delivers 8 watt per foot or 10 watt per foot. And that's kind of how we approach this type of quoting process. Because of course, most of the time, if we're trying to just to make the matter simple, right? If it's a 100-foot pipe, you very likely just need a 100-foot cable, unless of course there's some valves and stuff. But the wattage of the product is what's also extremely important, because just like Mary was saying, if it's a larger pipe and maybe there's minimal insulation, it is very likely you may need an 8 watt or 10 watt product or a double run of the cable kind of on each side, kind of like 7 o'clock and 5 o'clock position. So yeah, all of these pieces of information are critical. Majority of the time there's going to be some kind of plumbing plan or so that where all pipes are listed. Again, if you have that, just send it to us. Our design team will kind of get that and prepare a layout based on this. So again, that's kind of how the quoting is done for the pipe trace application. And it's, again, we do majority of that work for you. So uh, you're really getting the nice smart plan with electrical plan and layout plan ready to go.
Awesome, awesome. And something else I'll point out real quick too. Again, this is the time of year to plan these types of systems. So if you had some experience last winter with any ice damming or pipe freezing, please let us know. We would be happy to help you solve these issues. We do keep these products in stock, so getting them at this time of year is the right time of year to do it, because we know closer to fall, it gets too cold to get the tape and pads to adhere properly. So definitely get that stuff up there now. And I don't know if we got any other questions. I think we can.
Yeah, it looks like we got notifications here that there's no additional questions from Facebook. That's, by the way, where we are running this video session live as well. So if you trying to join us on the fly, or you just whatever, you forgot your login credentials or something, you can always jump on Facebook. We're trying to always have a backup stream running there, so feel free to join us there at any time. But yeah, that's, I think, all for the question. Go ahead, Mary.
Okay, so WarmlyYours here. We are always ready to help you. We have lots of great videos and tools on our website you can access at any time. We'd also like to invite you to join us. We do it 3 times a week, Tuesdays, Wednesdays, Thursdays at 4 p.m. Central Time. We pick some different topics to talk about, but you can always catch us live on these days and times, Tuesdays, Wednesdays, Thursdays, 4 p.m. And we'll be happy to answer any questions about Radiant products. The next webinar, of course, join us. We are going to be talking about radiant heating for wood floors. This is going to be covering the ever more popular floating laminate engineered and hardwood flooring choices. So this webinar is going to take place Thursday, August 14th at 1 p.m. So get registered. Our latest promotion is right now running through the end of July. We have the Temp Zone products on sale. This includes the Temp Zone Flex Roll, and it will also apply to the Temp Zone cables. This is for your indoor floor heating systems. So if you've got any projects like that coming up, we're happy to help you out with those as well. So thank you so much for joining us. Let's stay connected. So feel free to email us at info@warmlyyours.com. My name is Mary, here with my coworker Anatoly, and we'd like to thank you so much for joining us. And at Warmly Yours, be connected, be warm, and be radiant. Thank you.
Yep. Thank you, everybody.